So you turned on the tap, hot water came out, and somewhere in the back of your mind you started wondering how that big metal cylinder in your basement or garage actually pulls that off. Maybe you are about to buy a new one and want to understand what you are paying for. Or maybe something is acting up and you want to know what is going on inside before you call anyone. Either way, you are in the right place. By the end of this video, you will understand exactly how a water heater works, what every part inside it does, the difference between the gas, electric, tankless, and heat pump versions, and why yours sometimes runs out of hot water at the worst possible moment. I have spent weeks digging through manufacturer manuals and talking to people who repair these things for a living so I can walk you through it in plain language. You will not need an engineering degree to follow along. Let me start with the big picture, because the whole machine is built around one simple idea. A water heater does three things. It takes cold water from your home supply line, it heats that water to a temperature you set, and it holds it ready so hot water comes out the second you open a faucet. That is the entire job. Everything inside the tank exists to do one of those three things, or to keep the whole setup safe while it does them. One detail surprises almost everyone who looks into this. A water heater heats from the bottom, not the top. The reason traces back to basic physics that you can actually feel. Cold water is heavier and denser than hot water, so it sinks. Hot water is lighter, so it rises. Engineers built the whole tank around that behavior. Picture a standard storage tank water heater. The tall cylinder most American homes have. Cold water from the street comes in through a pipe at the top. But instead of dumping that cold water onto the hot water you already have waiting, a long plastic tube called the dip tube carries it all the way down to the bottom of the tank. That keeps the cold water separated from the hot water at the top. Down at the bottom, the heat source warms that incoming cold water. As it heats up, it naturally rises toward the top of the tank where the hot water outlet pipe is waiting to send it to your shower or sink. So the layering inside the tank is constant. Coldest water at the bottom getting heated, hottest water at the top ready to leave. When you open a hot tap, hot water flows out the top and the same amount of cold water flows in through the dip tube to replace it. The tank is always completely full. It never drains down while you use it. It just keeps swapping cold for hot. A small device called the thermostat is the brain of the whole thing. It constantly senses the temperature of the water inside. When the water drops below the temperature you set, the thermostat switches the heat source on. Once the water reaches the target, it shuts the heat off. That on and off cycle runs quietly all day and all night, which is why you usually have hot water whenever you want it. Now let me open up the tank and show you the parts that make this happen, because if you ever have a problem, these are the names you will hear. You already met the dip tube, the tube that sends cold water to the bottom. If a dip tube cracks or breaks, cold water dumps straight into the top of the tank and mixes with your hot water, and suddenly your showers go lukewarm for no obvious reason. Next is the heat source, and this is where gas and electric models split apart. I will come back to that difference in a minute. Then there is the thermostat I just covered, the part that keeps the temperature steady. Now we get to a part almost nobody knows about, and it is the single biggest reason a water heater lives a long life or dies young. It is called the anode rod. It is a long metal rod that hangs down inside the tank, and its entire purpose is to rust, so your tank does not. Corrosive water will always attack metal, and the anode rod is made of a metal that corrodes more easily than the steel tank around it. So the water eats the rod instead of the tank. People in the trade call it the sacrificial rod because it sacrifices itself. Over a few years, it slowly dissolves away. If nobody ever checks it and it dissolves completely, the water moves on to attacking the tank itself, and that is when tanks rust through and start leaking on the floor. There is one more part you absolutely need to know about, and this one is about safety. It is the temperature and pressure relief valve usually just called the T&P valve. As water heats up, it expands, and that creates pressure inside a sealed steel tank. If the temperature or the pressure ever climbs too high, say a thermostat fails and the burner just keeps running, that pressure has to go somewhere or the tank could rupture. The T&P valve is the escape hatch. If pressure passes about 150 pounds per square inch, or the temperature passes around 200 degrees, the valve pops open and lets water and pressure out through a discharge pipe until things settle down. It is a simple device, but it is the thing standing between a normal water heater and a genuinely dangerous one. So remember this one rule and never break it. If your relief valve is dripping or leaking, never cap it or plug it to stop the drip. That valve is the only thing preventing a pressure explosion, and blocking it is how water heaters actually burst. A dripping valve means something needs to be checked, not silenced. Okay, let me get to that gas versus electric question, because how your heater makes heat depends entirely on which one you have. A gas water heater has a burner sitting underneath the tank, like a flame under a pot. It burns natural gas or propane to heat the bottom of the tank, and the exhaust fumes vent safely out of your home through a flue pipe running up through the middle. Gas heaters tend to heat water faster, and they keep working even when the power goes out, which is a real advantage in a storm. An electric water heater works differently. Instead of a flame underneath, it has heating elements that sit directly inside the water, usually two of them, one near the top and one near the bottom. Think of them like the metal coils in an electric kettle. Electricity runs through them, they get hot, and they heat the surrounding water directly. Electric models turn almost all their energy into heat, so they are very efficient at the unit itself, but they reheat more slowly than gas, and they stop working during a power outage. To put real numbers on the speed difference, a typical gas unit can reheat a 50-gallon tank in roughly 30 to 40 minutes. An electric one might take 60 to 80 minutes for the same tank. That gap matters when your whole family is showering one after another. So far, I have been describing the classic storage tank, but there are three main types of water heater you will run into, and they work in very different ways. The first is that storage tank model we have been talking about. It keeps 40 to 80 gallons hot all the time, ready to go. It is the cheapest to buy and install, which is why it is everywhere. The downside is that it only holds so much, so you can run out, and it spends energy keeping that water hot around the clock, even while you sleep. The second type is the tankless water heater, sometimes called an on-demand heater. This one has no tank at all. It is a compact box mounted on the wall. When you open a hot tap, cold water flows through it and rushes across a powerful heat exchanger that heats the water instantly as it passes through. Because it only heats water when you actually need it, you never truly run out, and it wastes no energy keeping a tank warm. The trade-offs are a higher upfront cost and the fact that it often needs upgraded gas lines or electrical wiring to handle that burst of heating power. People misunderstand one thing here. Tankless means you get endless hot water, but it does not mean instant hot water. You still wait the usual few seconds for hot water to travel through your pipes to the faucet. The third type is the heat pump water heater, also sold as a hybrid model, and it is the most efficient option you can buy today. Instead of making heat directly, it moves heat from one place to another. It works like a refrigerator running in reverse. A refrigerator pulls heat out of its inside and dumps it into your kitchen. A heat pump water heater does the opposite. A fan pulls in the warm air from the room around it, a refrigerant absorbs that heat, a compressor concentrates it, and then coils transfer that heat into the water in the tank. Because it is moving existing heat rather than generating it from scratch, it can be 2 to 4 times more efficient than a standard electric heater, which can mean real savings on your power bill every year. The hybrid part means it also has regular electric backup elements that kick in when you need a lot of hot water fast. Now let me answer the question that probably brought a lot of you here. Why does my water heater run out of hot water? It comes down to two numbers that manufacturers list on every tank. The first is the first hour rating. That is how much hot water the unit can deliver during the first hour of heavy use, starting from a full hot tank. The second is the recovery rate, which is how fast it can heat brand new cold water back up to temperature after you have drained the hot. But there is a catch most people overlook. You cannot use the full tank of hot water. As you draw hot water off the top, cold water is filling in at the bottom and mixing, so you really only get about 70% of the tank as usable hot water before it starts going cool. Once you have used that, you are at the mercy of the recovery rate, waiting for the heater to catch up. So a long first shower, a couple more showers, a load of laundry, and a dishwasher cycle can outrun a smaller tank fast. That is not your heater being broken. That is just demand outrunning supply. While we are on temperature, let me cover the setting on your heater because there is a right answer and it affects both your safety and your wallet. Most water heaters ship from the factory set to 140 degrees. The Department of Energy recommends turning that down to 120 degrees for most homes. The reason matters more than people expect. Water at 140 degrees can give you a serious burn in just 2 or 3 seconds, which is a real danger with young kids or older adults in the house. At 120, it takes a minute or two to burn, far safer. On top of that, dialing it down from 140 to 120 cuts your water heating energy by around 6 to 10%. The one exception is a home with someone who has a weakened immune system because the hotter setting kills certain bacteria. If that is your situation, the safer move is to leave it at 140 and install anti-scald valves at your faucets. Last thing, and this is what separates a heater that lasts 20 years from one that dies in 8. A water heater needs a little maintenance, and almost nobody does it. 2 simple jobs make all the difference. First, drain and flush the tank about once a year to clear out the sediment and mineral grit that settles at the bottom. That gunk insulates the burner, wastes energy, and speeds up corrosion. Second, remember that sacrificial anode rod. Have it checked every 3 to 5 years and replaced when it is mostly eaten away. A new anode rod costs a small fraction of a new water heater, and replacing it on schedule can roughly double how long your tank lasts. Skipping it is the #1 reason tanks rust out early. So that is the whole machine. Cold water comes in through the dip tube and sinks to the bottom. A gas burner or electric element heats it. The hot water rises to the top and flows out to your taps. The thermostat keeps the temperature steady. The anode rod takes the corrosion hit so your tank survives. And the relief valve keeps the whole thing safe. Whether you have a tank, a tankless unit, or a heat pump, that core job never changes. It is heating water and getting it to you when you want it. If you want to go further with any of this, I have left some helpful resources for your water heater down in the description. Now that you know what is happening inside that tank, the whole thing is a lot less mysterious and a lot easier to take care of.